What up, YouTube? It's your favorite math teacher, Mr. Stevener here, coming at you with another video. Don't forget that button right there. I know every YouTuber says it, but really it's how I can send content to you guys, how I can get a hold of you, and so you can comment if you need some help on videos. Like I said, the last couple of videos, people actually asked for. This one, nobody's asked for, but I thought this was something to be really useful that you need in life. So if you're curious about what math you need in life, I'm about to show you one right now. So stick with me, watch the whole video, and if you have questions at the end, feel free to comment. Hey, Tommy, you want to come do a video with me? No. Sorry, guys, Tommy. Wait, what? Come on, get up here. They're not here to see me. Yeah, they are. They're not. They're here to see you. Come here.
Oh, hey, I don't want to. I don't like it. I don't like that. No.
Tommy, this one, hey, this one is going to be helpful for real life.
No math is ever helpful for real life.
Yeah, of course math is helpful for real life. I'm going to show you an example right now.
Oh, yeah? What's it called?
Don't tempt me here.
Ooh, I'm so scared.
Knock it off. Here we go. So, you're ridiculous. Knock it off.
Okay, sorry. I'm sorry. Not the look. Okay.
We ready to do some math?
Yeah.
Okay. We're going to focus today on equivalent. That's a fun word. We'll talk about it in a second. Equivalent ratios.
I thought you said I was going to use this in life.
You are. You are. Equivalent ratios is something you'll use in life.
Nuh-uh.
It will.
Nuh-uh.
Yes.
No.
Yes.
No.
Yes.
No.
Yes. No. Stop arguing with me and trust me. So, equivalent is this word. We'll break down real quick. Bam! Equivalent. Notice how it has this first part that kind of looks like the word equal? That's because equivalent really means the word equal. And a ratio, I know that sounds complex, but it's basically saying it's comparing two things, okay? And they are equal in quantity. So if one goes up, the other has to go up the same, so on and forth. That's a ratio. Okay? You with me? Equivalent ratios. Ratios. You look lost.
Yep.
All right. Basically, equivalent means equal. Stick with that in your mind. Stay with me, and I'll show you an example of this. Ratios are something that we see all the time in life, and I'm going to give you a great example of it. Just because this sounds complicated, that's just a math term you're going to hear, but I'm going to show you a simple term for it. We're pretend we're going to make lemonade.
Oh, I like lemonade.
Well, I actually have the best recipe for lemonade.
Nuh-uh.
Just pretend.
Oh, okay, yeah, good.
The best recipe ever is 2 lemons. Okay? To 3 cups of water. Okay? Now, I am telling you right now that is the best recipe of lemonade.
What about the sugar?
Okay, we'll pretend it's sugar water.
Oh, okay, sugar water. Yeah.
So, best recipe ever. So I'm going to ask you a question. Keep in mind, this is my best recipe. I'm telling you right there. Okay? This is the best. Bam. Absolute best right there. All right? With that in mind, I'm going to put a different recipe up, and I want you to tell me if it's going to taste the same. This is really important. Okay, so pretend you're drinking this lemonade. What was that?
I was gulping.
You were gulping? Wow, okay, that sounded not like gulping at all. But it's all right. Cool, gulping.
Yeah, it was.
Okay. Okay. Okay, jeez. All right, so what if I told you instead that my grandma, she disagreed with me, and she said that this is actually the best recipe.
Well, I kind of like your grandma. She cooks really well.
I know you kind of believe my grandma because she cooks really well, but check it out. Like my grandma says, hey, this is the best recipe. I said, nuh-uh, grandma, this is the best recipe, and we argued about it. Do those taste the same?
No, they can't.
And this is where this right here is super important, because you will find that actually these two things right here,
Yeah.
pretending that we made them, based on this recipe, taste the exact same.
No way.
Way. And that's all because of equivalent ratios. And let me show you why, and let me show you how this is super important. Okay? First off, ratios are literally, like I said, they're just a comparison between two things. So notice in my recipe, I said that 2 lemons to 3 cups of water, right? I told you that that was my recipe. This is my ratio. So this becomes my ratio I want to look at. It's 2/3, or 2 lemons to 3 cups of water. Notice it's a comparison of two things, or a quantity looked at with each other. You got me so far? Are you with me?
Yeah, I think so. But I don't see how grandma's is the same.
Ah, you don't see how grandma's is the same, and that's what I want to show you. And this is really important. Notice my recipe is really just a smaller amount than grandma's. Check this out. Watch what happens. I'm going to circle my recipe. It's 2 lemons, right? With how many cups of water?
3, 3, 3, 3.
So look, I'm going to circle that. See that? There's 2 cups. There's my recipe. You see it?
Yeah.
Okay, look, I'm going to do a circle, another one of my recipe. Look. Look, watch.
Wait, so grandma's recipe and your recipe are the exact same.
Exactly. They're equivalent because the only difference is grandma has more, right? It would be like me saying, okay, I make a batch of mine, and then I make another batch of mine, and I make another batch of mine, and I combined them all. Is it going to taste different?
No, it tastes the same. There's just more.
Exactly. Tastes the same. There's just more. That is what is considered an equivalent ratio. Okay, so let me show you what that looks like in a table real quick, Kami, because it'll help. We'll stick with my recipe, the basic one right here, with 2 lemons and 3 cups of water. Okay, we're going to look at that in a table real quick to try to help you understand this a little bit better. So if I have a table,
Oh, I thought you meant like a table that you sit at.
no, I'm talking about it like a math table.
Oh, math table. Yeah.
So lemons and water. Okay, and this is in cups. All right, so if I have 2 lemons, how many cups of water I need?
3.
3. Okay, and grandma showed in hers that if I have 6 cups, right?
Yeah.
That I needed, or 6 lemons, excuse me, I needed how many things of,
Water?
thanks, I couldn't think of the words.
Yeah, I got you.
Okay, so of water, right? How many were there?
There was 9. There was 9. 9, 9, 9, 9.
There was 9. You're right. These right here are equivalent ratios. Okay, so watch what I do, and this is what's really important, right? I could figure out what would happen if I needed 4 cups. What would it be?
Let's see. So 3, so 6.
Exactly. Notice there's a pattern. What happens if I needed 8 lemons? How much water would I need?
Let's see. You would need 12.
12. And all of these are equivalent ratios. And I'll prove it. Just one more way to look at it. So this is a ratio of 4:6, right? I'm going to rewrite this, okay, as a fraction, because a ratio is really another way. There's 3 ways to write ratios, right? You can write 4/6, you can write 4:6, or you can write 4/6 as in a fraction. All 3 of these are considered ratios, okay? But I like to put it in fraction form. And now look, if I simplify this by dividing each one of these by 2, notice I get 2/3, which is my exact starting recipe.
Oh, wow. Wait, all of them do that.
All of them do that, you're right, because there is an equivalent ratio. Are you with me?
Yeah, I think so.
Now, I'm going to show you something really cool. I'm going to add some crazy language to this, but this is also going to show that these are all equivalent ratios. Are you with me?
Yeah, go ahead.
So, if I divide this way, lemons to water, 2/3, right, I'm going to get 0.66 repeated, okay? If I divide 4 and 6, I'm going to get 0.66 repeated. This is 0.66 repeated. This is 0.66 repeated. Anytime I divide these, because all of these come out to the same thing when I divide them, that means they are required to be equivalent. And there's a really fancy word for this. It's called the constant of proportionality. I know that's a tough one to say, but believe me when I say the constant, wow, I think if I can write that word, constant of proportionality. I know that sounds really complicated, but it's a fancy way of saying when you divide all of these, if all of these are the same, that's the constant. That means they're all equivalent ratios. And here's why this is important. say you're cooking a recipe. Do you like to cook?
Yeah, I think so.
Okay. And it tells you that you have a pancake recipe, right? And we'll say you need 2 cups of, milk. You need a cup and a half of flour, and you need a tablespoon of, I don't know, what do you need a tablespoon of?
Uh, Vanilla?
Vanilla? Okay, there's a good call. Well, so we'll pretend that's what you need for pancakes. You need a lot more. But we'll say that this recipe makes it for four pancakes. But the problem is you have 8 people at your house.
Oh no! I would need to change the recipe.
But you want the pancakes to taste the same. This is where this ratio stuff comes in hand. Another thing that might happen, right, and you want these pancakes to taste the same, we'll pretend you're out of milk and you want 2 cups of milk, but you actually only have 1 cup of milk in your fridge, right? You can use equivalent ratios to figure out how much the other stuff you need.
Really? You can?
Watch. Using my favorite thing when it comes to rates and ratios, you can use a unit rate. Okay, let me show you how that works. So we'll pretend you only have 2 cups of milk, Tommy.
Oh man.
I'm sorry, 1 cup of milk.
Oh, even bigger now, man.
Yeah. So 1 cup of milk, right? So I'm doing a ratio, right? Right now, the ratio of cups to flour to make it taste the same is 2 to 1 and 1/2, or 2 to 1.5, right? That's my ratio, correct?
Yeah.
Okay, but right now I only have 1 cup of milk. Notice I can use unit rates to solve this. I need to know how much cup of flour I need. So to get from 2 to 1, what do I need to do?
Divide by 2?
Yeah, I have to divide. You're right. Anything divided by itself is just 1. If I divide the numerator by it, I have to divide the denominator. So I had to figure out what 1.5 divided by 2 is, which I know is 0.75. Right? So 0.75 is 3/4. So if I only have 1 cup of milk, I have to use 3/4 cups of flour for it to taste the same. And all I did there was use equivalent ratios and unit rates. All right? One more and we'll show you. We'll look at a graph again because I know that can be confusing. If somebody gave you a graph that, or a table, Tommy, that looked like this, and they told you, we'll go back to lemonade, that lemon and water, they gave you a ratio of 2 lemons to 4 cups of water was the best. You with me?
Yeah, I think so.
Okay, and they wanted to know what were some other equivalent ratios if they gave you this, and you had to figure out these. Okay, best way to do it, right? Figure out what your unit rate is. To do that, you divide these, right? So this is 4/2. I can write it like that. Water of a lemon, that's totally fine, is 2, right? So this is 2. I want this to be 2 and this to be 2 because my constant of proportionality needs to be the exact same thing. So how do I get from 2 to 4? Well, I multiply by 2, right?
Yeah, I think so.
So how would I get, I want this to be the same. So I'd have to multiply by 2. That would be 6. I have to multiply by 2. That'd be 8. Multiply by 2. That would be 10. Multiply by 2. That would be 12.
Oh man, I think I'm getting this.
Exactly. This is all, and trust me, this might be a video you have to watch a couple times. This is tricky, but I promise you it's something that you're going to use. All right? Using that unit rate, using that constant of proportionality, which those are interchangeable. People use those words, but you probably have never heard somebody use constant of proportionality.
Yeah, not till now. Now I have.
Now you have because of me. But really, unit rate is the same thing, right? So with that in mind, the takeaway from this, guys, 3 takeaways, right? You're going to use this when you're cooking. You're going to use this when you're making recipes. Really what you're checking for is you want to make sure that things are equal. So if I have 2/3 as a ratio, okay, if somebody put 4/5, I have to check if those are equivalent, right? The only way to check is divide and see if they come out to the same number. If they do, they are equivalent ratios. If they don't, they're not.
Oh.
Okay? But I also need to figure out different ways to find other ones. So if I have the unit rate, like say for example, I could find the unit rate for this guy, by the way. I would just divide by 3. I'd make it this one 1, divide this one by 3, and you get 0.66 repeated. So this is my unit rate, right? We'll say somebody said, hey, we'll go back to this as water. If I put 10 things of water in, how much do I need of lemons? Well, you do the same thing. You just multiply this by 10 since you have the unit rate, and that'll tell you if you have 10 cups of water, how much lemons you have. right? Which this would be 6.6. Right? This is all, I know it sounds crazy. I know, I get it. But believe me, you're going to use this. This is equivalent ratios. If you have questions down in the comments, let me know.
I still am a little bit lost, I can't lie.
Okay, well, I appreciate your honesty. And if you guys are too, let me know. I want to figure out how to help you, right? But really, guys, it's about seeing this, it's about practicing it. And Tommy, that's the big thing. And this is for you guys too, okay? And I'm not telling you this because, yay, I want to make a lot of money on YouTube. Because really, I'm here for you. If I make money, cool. But I'm here for you. I'm telling you, you might have to watch this video again. You might have to practice it. Math is like anything. You have to practice it. You can't just watch a video once and expect,
Oh, I get it.
exactly, you can't expect that. You have to watch it a couple times.
Yeah, I get it. I think, yeah, I watched the dividing the decimals thing.
Yeah?
I watched that like 3 times.
Did you? Did it help?
Yeah, I think so.
Well, good. I hope it did. I hope this helped you guys. I'm here for you. If you have any questions, feel free to let me know.
Yeah, or me too. You can ask me. Although, I'll just ask you.